Today we're doing piecewise defined functions. If we look first at the definition, a piecewise defined function is a function with different formulas for a different part of its domain. If we take a look at an example here, it's too close. Okay, yeah. This is an example of a piecewise defined function where you see this red part of the function is an exponential function of y equals x squared, whereas this blue part of the function is a linear function of y equals 6 minus x. If we take a look here, basically this function is made of two functions where for x is smaller than 2, it's going to be x squared, y is going to be x squared, and for when x is bigger or the same as 2, y is going to be 6 minus x. And if you look at the domain and range, the domain is basically, as you can see, it's going to be infinity to infinity because it goes on and on. But for the range, it's also going to be infinity, infinity, but for just both of these parts of the function, you can see that it's going to be different for the part of its domain. Whereas the sum of these two is going to equal infinity because this part on is infinity positive, but this part on is infinity negative. So if we put this as a one function, that's going to be equal to the range of negative infinity to positive infinity, just as here. Okay, so going on, we're going to take a look at absolute value function. So an absolute value function is going to look like this. Fx is going to be equal to the magnitude of x, where x for x is bigger than 0, and negative x for when x is smaller than 0. So if we just make sure that this is in set, then this is the kind of function we will get, or the kind of graph we will get. X, forgot to put that there, but that is the kind of function we will get. And that's pretty much all for piecewise defined function.